right, here we are with a very rare question all about angular momentum. We don't have many questions from the, let me get this right, A4 topic. So make sure you have a good go at this one, and then feel free to let me know if anything's not clear, because particularly with these ones, we really do need to make sure we get them right. Okay, so we're told the moment of inertia, I, and it's rotating again from rest. We've always been told rest. It's a really good point just to make sure we know the initial state of the system. Angular acceleration here, alpha, is constant. What's the change in the angular momentum when the system has made 4 complete rotations? Okay, 4 complete rotations, we're going to have to make sure we remember what that means. We'll come back to that later. So, for this, we're firstly going to use our equations of motion for rotational motion. Okay, now firstly we're going to start off with this one. This is our omega final squared equals omega I squared plus 2 times alpha delta theta. And this is going to be important because we want to determine our angular momentum. Angular momentum is determined by, amongst other things, our angular velocity. So to do this, we're going to have to recognize that firstly we are initially at 0, and so therefore we simply can consider a reduced form of the equation. Our omega final squared is just 2 alpha delta phi. And delta phi in this equation is going to be 8 pi. Why is that? Well, we're told 4 complete rotations. 4 complete rotations means 4 times 2 pi, 4 times 2 pi, 8 pi. So we end up with our 16 times alpha times pi. If we then go and think about our final angular velocity, well, that's just going to be the square root. It's going to be square root of 16 is 4, and then we've got the square root of alpha times pi. It's worth looking again at this side here just to check, is there any pi's here? Looks like there's going to be a pi in our answer, so we're looking at either A or B. Okay, why is that important then? Well, the angular momentum is simply the moment of inertia times the angular velocity. We know the moment of inertia is I. We know our final angular velocity is this 4 times square root of alpha pi, which is why our answer here is B.